Thanks so much, Mark and Mikael. It's a great pleasure to have the opportunity to speak in the hybrid group. The three of us know each other for quite a long time, from the lucky situation I'm in to be able to or to be allowed to speak at international conferences as well. So I was in the lucky situation to get to know you already a few years ago. And yeah, it's a great pleasure, as I said. Thanks for introducing me. I will try and make this running. I hope you can see my screen. As you already mentioned, I want to talk about modeling in Power BI, and my goal for today is to give you a rough overview, maybe not from the earliest start, but a rough overview about Power BI, about modeling itself, about basics of data modeling, but really just a quick overview, some basic principles that are important, especially talking about modeling in Power BI to really achieve good results. And then we have the topics of shaping the data coming from the data source, because you won't always be in the lucky situation to have a relational data warehouse in the background, which you can just connect to, but you might to connect to data sources from different systems, from different surroundings, from different purposes, and you might need to shape the data into a good data model. We'll talk about enhancing the data, so actually adding business intelligence, business logic to the data. I actually skipped security, so we don't have any slides for this, but I will roughly mention how we set up security in Power BI models, so just a very quick detour. And then that will be the part where I want to come up to as quickly as possible, because I want to show you some things about advanced modeling in Power BI. So actually showing you some of the cool features that are available in Power BI that might help you to solve really more complex, more demanding use cases and business requirements, and some really cool things that happened in the past. As maybe you can already guess from what I told so far about the agenda, probably every of those topics is something where we could talk about hours and hours if we want to. So this will be more or less a rough overview. I hope this will still help you to gather some thoughts, to gather some inputs or ideas about the different topics. And I also added some references at the end to the slide deck with really good sources like blog posts, like documentation, like videos, and so on, where you can actually get more detailed information on the different topics when you're interested. Because it's really 1 hour is a perfect time for speaking, but it's unfortunately not enough to go into details of in all of those topics. Okay, so let's get started. Power BI, short overview. Before we start with basics, just I guess almost everybody of you will have heard about Power BI or worked with Power BI, but just as a very quick introduction, Melissa Coates is a really, really amazing Power BI MVP. She's really amazing in a lot of things about Power BI, but especially in terms of governance and administration of Power BI. And she has a very interesting website where you can watch all her content, her webinars, and so on. And she also keeps track of this really amazing overview of everything what is available in Power BI. And as you can see, the last update is just very recent. So if you're looking at this, you see this is a huge amount of different topics and areas that are all related to Power BI in some ways. And what we actually want to talk about today is just this small part, a very small detour to row-level security, as I mentioned. And then we will spend a looking at this part. This is something which really is helpful talking about advanced modeling, where we will come to in the end. But actually, this is more or less everything of the whole area of Power BI and Power BI experience that will actually be sufficient for a 1 hour talk today. And what you can already see is the main thing, the main tool we're talking about here is Power BI Desktop, this one. It's a very, very rough circle. That is the main developer tool that is used to actually create everything in Power BI. You're using it to shape the data, you're using it to create your data model, you're using it to create your reports. So you're doing more or less everything in Power BI Desktop, and that's the tool where we want to look into later on. And as you can see, this amazing overview of all those features Power BI is related to already can give you a hint that Power BI is not just a single service, not just focusing on one functional area, but it is a real integration software or integrated software, which actually means it builds a bridge over different functional areas. It really combines different functional areas, which is the part from data integration, data modeling to visualization. And it includes opportunities for data analysis, advanced analytics, and it also offers opportunities for DevOps. I tried to highlight which parts of those are actually currently useful for self-service BI, which was the original purpose of Power BI. It was really meant as a self-service BI tool, actually originating in the former Excel Power Pivot and later on Excel Power View, so those Excel functionalities for analyzing and creating reports. But Power BI more and more grew into an enterprise BI solution. And with most of the parts like data modeling, visualization, and data analysis, Power BI offers very, very not even sufficient, but very useful and good opportunities to be used in enterprise BI as well. Data integration was a part that was a bit awkward in the beginning, but it's getting better and better. Data flows, for example, is another kind of ETL part, which is based on the Power BI solution, but is not part of the Power BI desktop part, but a different part. And this is actually also growing better and better and allowing the users to do more and more in this term. What is a little bit lacking behind at the moment is DevOps part, so the application lifecycle management. There, Microsoft offered a first solution last year, which is actually generally available since a few months, but it's very useful already for the self-service part. So deployment pipelines, that is how it's called, can be set up in the Power BI service and can be started manually and gives you a good overview of a lot of things you can do to help you move your content between the different environments in your application lifecycle management. But what is lacking is especially the integration into the standard DevOps tools, like, for example, Azure DevOps into deployment pipelines and so on. And there is no official API or no API for it. So there is no real way for the, let's say, the IT department, the infrastructure team inside the company to help you support this in an enterprise BI way. And that is where it's lacking a bit. But this is also on the roadmap, and the announcements on the roadmap are actually out when this should come and when we can count on this. So all on a good way and all progressing really good. So Power BI. As we saw, data modeling is one of the functional areas of Power BI, and one of the functional areas Power BI really is already rather advanced. This is basically easily to explain because the data modeling solution inside Power BI is based on another modeling solution of Microsoft's, which is on the market for quite a long time. It's called Analysis Services, or SSAS. In the first part, SSAS was especially used in the classical multidimensional world, in the multidimensional functionality with cubes, combining dimensions and measure groups to actually build up classical cube analysis solutions. But with SQL Server 2012, we had the feature of Analysis Services tabular mode entering the SQL Server world, again based on the Power Pivot solution in Excel, both based on the so-called VertiPack engine, which is designing a more tabular-based look onto the data using column store indexes to actually highly compress the data, make it easily searchable, and tables and relationships between tables are the baseline for this kind of modeling solution, and you can create measures and calculations on top of this to actually fulfill all the analytical part. But this kind of tabular model still has some requirements about how a data model should be set up so that you can actually use this functionality efficiently. And first of all, let's start with some reasons for a proper data model. Why is a proper data model actually useful and helpful? First of all, it's easier to understand for the report developers. So in most situations where I'm working at, there is a different group of developers who are creating the visualizations, the actual reports, and developers who are creating the data models. Data modeling is a very, let's say, special word. People might have a different way of thinking than others. I don't know. I'm a data model developer most of my life, so I'm allowed to say that. No, but it's a smaller part of the BI developer part actually, at least in my experience, and so you always have to solve the situation that you are creating a data model, and you have to make this intuitively understandable for those people who are creating reports on top. And in the current times, those report designers are not only your colleagues from the IT department who are actually doing this, creating standard reports for the report consumers, but as I mentioned, Power BI was originally a self-service tool, and the self-service part is growing more and more, is getting more and more important also in the enterprise BI perspective. So in most companies where we are working with Power BI, there are key users in the different business departments who are extensively working with Power BI, either in creating their own data models and then maybe passing it over for the IT for refinement and automation and maintenance, or at least they are creating their own reports and analyses on top of the existing data models. So the easier understandable a data model is, the less knowledge transfer you have to provide for the report creators to actually find their way around those data models. Apart from that, even for you as the IT department, it is easier to maintain a data model where the relationships between the data, where the origins of the data, and where actually the calculation ways of the data are easy to understand and easy to grasp. Because in case of errors or issues, it will be easier to actually do a root cause analysis of what is actually causing this kind of behavior or issue that you're looking into. And last but not least, a proper data model design can actually improve the performance. And that means the performance of the load processes itself, so actually uploading the data into the model, as well as the performance of the queries. And that is the one performance that actually hurts most if it's not good enough, because that will affect the end users, the consumers. And well, you all know how quickly you get results with searches in Google. You get your Amazon recommendations or whatever you're doing, or you're asking Alexa something and get a quick reply. We are not used to waiting for results any longer. We are expecting results to be there instantaneously. And that is the same kind of expectation that we are having also towards our business solutions. What are typical types of data models? We're not talking about good data models here. We're just talking about typical types of data model. The first one, and that is actually how most people get started when they are starting their first data model, is to create a large, flat or denormalized table, meaning you're just making like a kind of big Excel spreadsheet, putting everything on one sheet, having all the different values on the same table or the same sheet, which might be a bit awkward to get there in the first place. But when you have everything together, you don't have to spend time or thoughts on how is the relationship between different columns any longer, and what I need to do, where do I need to put a filter on which table to get that result, and so on. You have everything in one place. And that is something which, for a start, is rather easy to handle when you get there to a good result. But from a modeling perspective, that's not optimal. The second one, it's actually like the middle between the flat and the last one, the Snowflake schema, is the so-called star schema. With the star schema, you differentiate between two kinds of tables. One is the fact table. Those are normally tables with not too many columns, but a lot of rows containing all, for example, the transactional data, all the sales, all the inventory, all the work times, whatever you want to analyze. And they mostly contain numerical values, either the values, the key figures, that you're using to really do some calculations like your net sales, your prices, your costs, your worked hours or something like this. And it contains references to the other table type, the so-called dimensions. And those references in an ideal world are numerical values as well, because numerical values can be compressed in the best way, and they can be searched in the best way. That's something where computer algorithms are really good. And the dimension tables contain the same kind of references, so the key columns that contain those numerical values that are also referred to in the fact tables, and they contain descriptive attributes. Those attributes are used to allow the report users or the analysts to create a context which will give the aggregation of the key figures from the text value a meaning. So having the information that you have an amount of 250 billion of sales is quite interesting. But if you don't know which companies, which customers, which time, which country, which whatever, still makes this a quite high number, but you're missing the context. You don't know how to actually treat this number. And the descriptive attributes in the dimensions actually allow you to put a context around this key figure, around this measure, and to actually understand the meaning of this key figure. And that is what the dimensions are for. And the way to do this, the way to actually create this context is by assigning relationships between the fact table and the dimension table, and those relationships are based on the references that are contained in both table types. And it's called star schema because in a simple data model, you will have one fact table in the middle, and the other dimension tables are actually surrounding this fact table like the bars of the star. And the last typical data model type is a Snowflake schema, which is basically a star schema in the first place. But here you are looking more into a normalization approach like you would do in a good database design. So for example, if you're having a dimension called sales representative and a dimension called customer, those two dimensions typically have something in common, which is, for example, the address. In a star schema, you probably would keep the data redundant. So the address fields for the customer would be part of the customer dimension table. The address fields of the sales rep would be part of the sales rep table. In a Snowflake schema, you would actually extract the address fields of both dimensions and would combine them into a separate address entity or address table. And both the sales rep and the customer table actually would have a relationship to this address table. And the more you're doing this, the more you're splitting up your dimensions in logically separate parts to actually increase your level of normalization, the more this star schema will look like a kind of snowflake, because you will have more and more relationships and more satellites. And if we're comparing this, those three data model types from a Power BI perspective and looking what is actually good for those, we see, and that's not surprising because I already hinted at that, that the star schema is the best. The reason is it is easier to understand, easier to follow up on as the flat table, because you don't have all the attributes in one large table. You don't have one large list of columns, but your attributes and your facts are split up into logically entities, into clusters, like everything for a customer can be found in the customer table. Everything for the sales rep is in the sales rep table. All the facts, all the key figures are in one table. So you already have something with that helps you search. On the other hand, the Snowflake would offer this as well, even better. The clusters would be smaller, but here it's getting more complicated because you have more complex relationships. Sometimes if you, for example, want to put a filter on an address, you really would have troubles finding out if that address is actually assigned to the facts via the customer or via the sales rep and so on. And so finding the attributes is easier. Finding the right path from the attribute to the fact table, finding the way of the relationships gets more complicated. The flat tables also have the disadvantage that by creating this large table containing all the information, you have to multiply all the relationships to get there. So typically your amount of data will increase. And talking about the tabular mode, as I mentioned, we will do a columnar compression on the tables, and those large tables are rather bad for a good compression result. So probably your models will get bigger even though you have only one table. This is just a quick summary of all of this. But as I mentioned, I will happily share the slides and you will see this. Actually, I think I have about 43 slides. I don't intend to discuss all of them, especially talking about shaping the data and enhancing the data with DAX. I just added some basic principles there, which I think are important for you to be able to look up afterwards. But really, digging into all those details today will just be too much. Just to mention this, so this won't be an issue. So, but when we're talking about data modeling, there is a flow of steps that you actually need to follow from extracting your data from the data sources up to being able to analyze the data in your model. And there are some tasks that you need to do, and I just wanted to try and give a quick overview of which of those tasks can be fulfilled in which of those steps, maybe even in the best way. So when you're starting extracting the data from your data sources, what you're typically doing is extracting the data, filtering it down to the amount of data that you actually need. So don't take data with you that you don't need. We're still talking about data models where you might to upload data. So the less data you need to upload, the less data you need in the processing phase, and the less data needs to be searched during query phase. So this is a performance factor. So filters is a thing. You want to cleanse the data. You want to make sure that the data is correct. You want to transform the data from maybe a different schema in the data source up to your star schema that you want to achieve. And you want to enhance the data with calculations already. So let's start with the first part, filtering and cleansing the data. If you have data sources like example SQL Server or Oracle or something like this, those are very, very good at doing those tasks. And all the tasks where the data sources are good at in this regard should be executed in the data sources. If they are not, if the data sources are not good at this, for example, if you're connecting to files and you don't have the possibility to do those steps there, you still have the possibility to do this in Power Query. Power Query is the part of shaping the data where we will look into later on. But those steps should be executed in the shaping phase at the latest. Then you have the steps of calculations. I already mentioned that you want to enhance the data, enrich the data with calculations. And as long as the calculations are based on one data source only, still it's optimal to do it in the data source if possible. It's still possible to do it in the shaping phase. And in some cases, it might even be advisable to do it in the enhancement phase in the data model. But as you can see, there is a prioritization. If you want to enrich with calculations based on multiple data sources, you cannot do this in the data source most of the times. So you have to do it in the shaping phase in Power Query, or you could do it in DAX. This really depends on the calculation type itself, because DAX is in some cases a better choice because calculations might be easier here. From a performance or from a resource perspective, Power Query might be the better solution because everything you do before you're uploading the data in the actual data model, so everything you do in Power Query instead of in DAX. So Power Query is before processing, DAX is after or while processing. So everything you do before you get to the data model can lead to a better compression result. So this might lead to less data, less storage you need, or even a better performance during query time because the indexes might be better. The last part, which is really interesting here, is calculated tables. Calculated tables is something which might help you achieve certain goals. Like in the tabular mode, you don't have this kind of, for example, non-visual totals that you had in multidimensional, meaning, for example, that the country user is not allowed to see the value of other countries than the one this user is actually assigned to. But on a higher level, on region or on world level, he should see the results of all countries, not only of the country that person is assigned to. And that is something which we call non-visual totals. And that is something which basically in a tabular mode cannot be achieved in a consistent way, because you can only aggregate what is there. If the user does not have permissions on the data of the other countries on country level, you actually just cannot aggregate the data up. But you can solve this by preparing calculated tables on different granularities. So you can prepare a calculated table that already contains the aggregates of the respective key figures on region level, for example. And then you can set up your row level security there. So on country level, the user is only allowed to see the one country. On region level, the user is allowed to see everything, for example. And as security is catching inside a data model, after the processing, but before the calculations are done, more or less speaking, it means that the data that is processed originally in the tables actually cannot be used, but the data in the calculated tables can be secured differently. And that is something which makes it rather interesting to be used here. And actually, that was, I'm sorry about that, that was not completely. Actually, it was completely wrong what I said. Security is catching after the calculation phase, but it's catching before the measures are calculated. So forget what I said a minute ago. Let me try it again. So the calculation tables are created before the security catches. So at this point in time, before security is applied, still all the data is accessible. So the calculations, the calculated table on a higher aggregate can be calculated based on all the data. Now security is catching when you want to calculate the measure. The measure would be the sum of sales on country level, region level, world level. And if a user is executing this measure, security will apply. And if you don't have this calculated tables with the different aggregation levels, the user, because of the security, will only get the result for the one country. With the calculated tables applied, the user can get the data from different aggregation levels, and so we can get to the result that we want. This actually allows us to perform the calculated tables or create the calculated tables in both scenarios, either in Power Query already before or in DAX, because also the DAX calculated tables are executed before security is catching. Okay, that was a lot of information already without much to see. So I will jump over the next two parts quickly just to get into the mood of showing you something. And we will see of some of the tasks, so the shaping and the DAX calculations in those examples as well. So shaping the data is the part which I meant in the actual data warehouse implementation. That might be like the data transformation, like the ETL phase. And this is done with a tool called Power Query. Power Query is this feature that you're using, and M is the name of the formula language that is used in Power Query. M is a case-sensitive language, a formula language, and it's used to describe and execute sequential steps. That is something which we best look at in the Power Query front end later on. Power Query offers you a front end to actually simplify the creation of those M scripts, but you still have the possibility to edit the scripts as well. And Power Query is not only part of Power BI, but it's also part of Excel, analysis services, Power Automate, and so on. You see all of this here. So this is something like a one-size-fits-all tool or approach that Microsoft is actually trying to include in a lot of tools and approaches at the moment. There's a lot of connectors to different data sources. Not all of implementations of Power Query support all of the data sources, but luckily Power BI actually supports most of it. So the last time I counted, 134 from the 135 connectors were supported. And if the connectors to the data sources that are available are not sufficient, you have the possibility to actually implement custom connectors by yourself. As I mentioned, a lot of those slides are meant to be a kind of reference to actually remember what I said or to look into more details, to give a little bit more context about all the content. But just saying, when you're setting up a connection to a data source using a connector, you have to decide about how to store the data. Either you want the data to reside in the data source, which is called direct query in general, or you want to import the data. This is the typical analysis services mode. So you're describing not only the metadata of the model, but you're uploading the data into the model, compressing it, and running the queries against the actually compressed data in this in-memory model. Live connection is more or less a kind of special way of direct query. It's direct query against a multidimensional model like analysis services tabular, multidimensional SAP, BW, or so on. It's not really the same as direct query, and we want to have a look at this at the end at one of the examples. Data sources can be located in on-premises system or in the cloud, and generally speaking, if they are on-premise, you need a gateway to actually allow for a secure transfer of the data from on-premises to the cloud. But the gateway has more advantages as well, like, for example, the possibility to add drivers that Power BI is not bringing out of the box, or it is necessary if you are writing a complex data source query that in one query is already combining data from different data sources. That is something which is possible in Power Query, and that will actually require the usage of a gateway. Data source authentication allows for different types depending on the data source. Typical ones are basic authentication like SQL Server authentication for a database, for example. You can use Windows authentication for some tools, or authentication too, so the actual Azure authentication. So this is all possible. Some of the data sources also support single sign-on, which is especially interesting for data sources that you want to use in a direct query mode, because in that way your sign-on actually needs to be transferred down to the data source to allow you to query the data from the data source in the context of your user of your credential. And we have two other topics I quickly have to introduce, which are native queries and query folding. Both are talking about a similar scenario, which is especially, again, in the terms of direct query. If you are writing a query against the direct query data source, you're having a Power BI visual. This visual will create a DAX query. This DAX query in a direct query data source scenario will be translated into a query in the querying language of the data source itself. So in case of SQL Server, you will get a T-SQL statement that is pushed down to the data source. And even in import mode, even if you want to upload the data, in this case, Power Query instead of the DAX engine, even the Power Query engine will try or will need to translate the M script into T-SQL statements, or it will try to do that as far as possible. So the start is always the same. If you're connecting to a SQL server with M, the data, for example, from the table that you selected needs to be uploaded. But if in the M script you're, for example, applying filter steps, Power Query is clever enough to actually try and translate those filter steps into SQL statement, into a where statement in the SQL query that is pushed down to the SQL server. And this pushing down of logic into the data source to apply as much of the logic on the data source instead of in the M engine is called query folding. And the same principle you can actually achieve by applying a native query. A native query allows you to to actually pre-write the query that is sent down to the data source to be executed there. So the principle is the same. The difference is native query is provided by you. Query folding is done by the M engine as far as possible. We have a reference of M, seeing some of the attributes and literals and elements, but we will have a quick look into this later on in the demos. As you see, a lot of reference here. The next, oh, sorry, I jumped over DAX. I'm sorry. So after M, we're actually jumping into DAX, which is the enhancing the data part. So M is used to shape the data, so to get from your data sources into your original star schema. So afterwards, you have tables like effect table and several dimension table. What do you not have at this point in time? What you don't have is, first of all, relationships. Relationships is something Power BI will try to guess if you let it, but you need definitely to make sure that relationships are set properly. And what you don't have is measures. So the actual calculations on top. How should the key figures be aggregated? Should there be applied any kind of specific filters? Should the calculation be differently depending of a certain context of a certain level inside a hierarchy? Hierarchies is something which you don't get in the data model originally. All of this is done in enhancing the data. Some of this, like setting relationships and creating hierarchy, don't require us to actually write DAX codes, but measures, for example, or some of the calculations like calculated columns or calculated tables require us to actually describe in a certain language how to do this. And this language is DAX, the data analysis expressions language. It's similar to Excel, but I just this day had a discussion with a customer who says he's used to writing different kinds of data languages, but DAX is really complicated. And the complication in DAX actually doesn't come from the, let's say, complicated function names or anything like this. Actually, those are quite easy to understand, but DAX is working with contexts. It's working with filter context and row context, meaning you always, it's not like with MDX. With MDX, you always had a kind of navigation throughout the data. Data knew about its place in the whole cube. It knew about its children, its parents, its neighbors or siblings, however you want to call that. And you could just play around with relationships between different members inside the data. DAX is table-based. So whatever you do, you will always need to put a filter context on top. So if you want to calculate something like the share of the total, you will need to calculate the aggregate for the current filter scenario, and you will need to aggregate the total value, and then you will have to perform a division. So inside the same calculation, you will need to shift the filter context from your current filter to the total value of the table, for example. This is filter context. That is something you need to know. And if we're using DAX in calculated columns, you need to perform a calculation based on the row in the table you're actually in. So you will need to tell DAX that the row you're currently in is your current filter. And that is something, those are basic principles that you need to understand if you want to work with DAX. And yeah, as I already mentioned, it can be used to calculate columns, to calculate full tables, to calculate measures. And it can get from rather simple scenarios to rather complex scenarios. And I definitely for sure mentioned the SQL BI team, the two Italian guys, Marco Russo and Alberto Ferrari. Those are the masters of DAX. So if there is a kind of DAX problem, they will have an answer to it. If they don't have an answer, there isn't any. But I was in the lucky situation to attend one of their DAX courses quite a long time ago. It helped me understand some principles, but I will never forget Alberto saying, DAX is different than other languages. If you have a specific problem and you try to Google for it, if you find a solution or a problem that is similar to yours, the solution you find will most probably not help you solve your own solution. because this scenario of contexts and filters you need to apply is so specific for each and every scenario. Of course, there are patterns and basic principles for sure, but finding a Google answer to a real specific complex scenario is probably not working, because it even might solve the issue in one specific context, but if you're changing the context, the filter, or anything else, it might do something completely different. So DAX is something which only works if you understand what you're doing. And that is kind of frightening, I think, but it still makes the whole experience of getting your DAX riddle solved also kind of adventure. Okay, again, some more background to DAX. And as we are forward, okay, we have a quarter of an hour left for the most important part, the advanced modeling. And that is something which was also mentioned in the abstract of this session. I already mentioned that Power BI is actually using analysis services tabular mode as the modeling technique. And what does this mean in comparison of analysis services? How is it behaving in comparison to analysis services standalone? And Microsoft officially announced, I guess in 2019, that Power BI is becoming a superset of the whole analysis services landscape. You can even see this in the documentation. Analysis services moved from the data platform area into the Power BI, and by this into the business application part. So analysis services standalone will not be the leading system. It will not die. It will not be removed or taken from the market. It still has a lot of users and customers and a lot of life by itself. But Power BI will become the leading system. Every new feature will come to Power BI first or at the same time as to analysis services standalone, which means Azure Analysis Services and Analysis Services on-premise. And not all of the new features will be shipped to Analysis Services standalone. Some of the features, and we already see that here, are exclusively used in Power BI. So talking about the features that I mentioned here, we have as features of Power BI incremental refresh, which is another kind of term for partitioning. In Power BI, you get a kind of framework that allows you to set this up rather easily. One of the examples I want to show you in 2 or 3 minutes, hopefully. This is a feature that is available in analysis services since ages. Not in tabular mode, not from the beginning, but for quite a long time. So this is rather new to Power BI. So another topic, Power BI was a different code stream than analysis services standalone. So there were some gaps where analysis services had some functionality that Power BI didn't. And the team worked hard to close those gaps. There are still some gaps, that is on one of the last slides, but those gaps are getting smaller and fewer. And incremental refresh was one of the gaps, and actually the Power BI models were hidden most of the time, but with Power BI Premium, a special version of Power BI which allows the customers to work on their own dedicated capacity, like a kind of their own server, Microsoft actually opened the so-called Xmla endpoints. So the official endpoints that are also used for analysis services, for other systems to connect to it, for Visual Studio, for Tabular Editor, for reporting services, even for Power BI to connect to analysis services tabular. And the same interfaces, of course, existed in the analysis services that are used inside Power BI, but they were hidden. And for Power BI Premium, both the interfaces for read and write mode are generally available and open now. So you can use the same tool set to work with the data models in Power BI Premium. And by this, you can use the same partitioning approaches that you used for analysis services standalone before, now for your Power BI Premium data sets or data models as well. For Power BI Pro, you don't have that functionality, but at least this is something which came up to Power BI. So you don't have the XMLA write endpoints, but this is something which came up for Power BI during the last few months. Large data sets. Why is this something which needs explaining? So with Power BI Pro, you only have the opportunity to upload a data model to the service with a size of up to 1 gigabyte of total size. So the PBIX file the data part can be up to 1 gigabyte. With Power BI Premium, they extended it from 10 to 12 gigabyte, I guess, which is rather large. But this is still very limited in comparison to analysis services standalone, where you can, let's say, have data models up to 200 gigabyte of size. And that is something which was a limiting factor, because if you want to use this as an enterprise tool, not only for reporting, but also for data modeling, you would need larger modeling sizes. And so Power BI retrieved a feature called large data sets, which actually allows you to change the storage type of your data sets and allows you to actually create data sets inside the service which are larger, so larger than 10 gigabyte up to the maximum size of the capacity you're actually renting for Power BI Premium. So this again is a premium feature only. You can configure this so you can limit the size the data models can get, but you have the possibility to create those large data sets as well. A standard feature for analysis services standalone. Calculation views was the very first completely new feature which came to both services at the same time. So Power BI got it maybe a bit earlier, and actually that isn't true. Analysis services got it earlier. It was in Power BI available as well, but there was no front end for it, so no way to actually create them. And that is something which I want to show you, but calculation views as a quick explanation is maybe a thing like scoped assignments. If you're aware of the multidimensional part, it's like a kind of pattern behavior for certain calculations, so that you don't have to rewrite a certain behavior for each and every measure, but you can define something like a kind of measure, typically used for currency calculation or time pattern behavior like previous year, next year, full year, quarter to date, and so on. And in the past, you would need to write quarter to date, for example, for every key figure, so for sales, for costs, for budget, and so on. And now you can have a dimension saying, I want to use the key figures, sales and budget and costs and whatever, with the calculation pattern of quarter to date. That makes it much better to maintain and much easier to use. Composite model. And that is composite model and aggregations work together hand in hand. And this is the large difference, and that is why we need to mention it here, between Power BI and analysis services standalone, because this feature for sure is Power BI only. And it means when you're using a direct query connection inside your data model, in the past, in both the systems, this would mean you cannot use any kind of other data source. No other direct query data source or no file-based data source or import data source. And with composite models in Power BI, you can do exactly that. You can combine different direct query data sources or direct query and import data sources. And that is something which is not available in analysis services standalone. And this really is a limiting factor. But after talking that much, there is some explanation to those different approaches as well. We want to have a quick look, at least a few minutes, into Power BI just to show you some very quick examples. And let's get started. I will open the incremental refresh as well. I have a few demos. Let's get started with incremental refresh and aggregations. So, okay. Let's get started with aggregations, because that is containing composite models as well. And I will try again to work with Zoom it. We are inside Power BI Desktop. We are inside the modeling view of our model, and we see a very simple data model. This is based on New York taxi data, but only a small set. What you see is your fact table in the middle. It's the trip data. You see different dimension tables like licenses, medallions, geography, time and date. And what you see on the right side is something which is colored differently because of a different data source, a different storage mode, which is called VFact trip egg, and that is an aggregation table. So I was talking about storage modes, and that is the most interesting example here, because what we are getting here is all based on one and the same SQL Server database. But what we are treating this differently, because what we are doing here is all our data, our dimension data and our fact table with the trip data is actually residing inside SQL Server. All of those tables are actually stored, and that is something which you can see, and that is the baseline for, as I mentioned, composite models are stored in a direct query mode. And with composite models, you were enabled to actually distinguish or define the storage mode on table level. So for each table inside this model, you can actually define if this table is stored in direct query or in import mode. And there is a third mode called dual, which is, as you can, which is used for, let's say, dimension tables, which are combined with a direct query fact table and an import fact table. Those dimensions are best stored in dual mode. You are not forced to do it, but it's the recommendation. Meaning, if you're sending a query against the trip table in direct query, this query will be translated into SQL and will be pushed down into the SQL Server to get the results. Why should you do this? First of all, if you have a real-time scenario, if you don't want to have the necessity to upload the data from the data source into the tabular model, again, another loading step which you might want to actually circumvent. The other solution or the other reason might sound a little bit weird, because direct query normally is a bit slower than import mode. But the other reason is if your amount of data is too large. So you could ask, if that amount of data is too large, is that really, really slow? Yes. But if the amount of data is too large to actually fit into a data model that is allowed inside Power Query, then how would you treat it differently? If this amount of data cannot be compressed enough to fit into the allowed amount of data in your data model, you only have the opportunity to leave it in the data source and query it on runtime. And this, to actually improve the performance for the users, this is the reason for aggregations. So what you're doing here is you're leaving your detailed fact data in the data source, and you're creating an aggregation table, a pre-aggregated version of this fact data, not for all dimensions, but for a subset of dimensions. And you can either leave this in direct query mode as well, or you can import this aggregation table into your data model to retrieve the best results. A typical scenario is you have a starting view in your Power BI dashboard with a top-level view doing aggregations on the highest level over everything. And then you have a lot of detailed views where you apply a lot of filters. So you're only querying small subsets of the total data. That is the best use case for aggregations at all, because you can make the top-level view aggregating all the data, use the aggregation table, and the detailed views are very highly filtered, so they only need a small subset of the data, and those can be actually gathered from the data source itself. And you're defining these aggregations by managing the aggregations in the aggregation table itself. And by this, you can, for example, say that the column count rows in my aggregation table is a count table rows aggregation of the trip table, or the sum passenger count column in my aggregation table is the sum aggregation of the passenger count column in my trip table. And what is interesting as well is my column month name in my aggregation table is a group by of the month name in my core date. And that is another interesting feature of aggregations, because if I don't want my aggregation table to be connected to the date dimension, because I don't want to have the data on day level inside my aggregation table, I still can create a link between the aggregation table and the date table and force the system to actually use the aggregation table for certain queries by setting up those group by functions. And how do I find out if those aggregations are really used? And here we come to the external tools, which I already mentioned. And you have 3 external tools available in Power BI at the moment. Tabular Editor, which is a tabular model designer, which help you advanced modeling on your creations. You can create calculation groups with it. One of the most interesting features. You can easily handle and treat your measures and all of your model. You have the Alm Toolkit, which is a schema comparison tool for Power BI models. So it's the Power BI version of the BISM normalizer, which is an extension for Visual Studio for analysis services tabular models. And you have the DAX Studio. And DAX Studio is the interesting part we want to look into here, because DAX Studio allows you to monitor your analysis services models, so also your Power BI models, and to run query against those models and to read, for example, server timings to analyze your results. And I created some queries and I'm connecting my DAX Studio against this aggregations DB source, the Power BI model that you're seeing here. And now, if we remember from the model, my aggregation table is connected to my medallion dimension. So if I do a query giving me the sum of passenger count for all my medallions, I can run this query. The query is blazingly fast. If I run, for example, this query against Hackney license, this will cost too much time because we cannot wait for the result. But let me say this is really fast. And if I look into the server timings, I can see some results from, do you remember SQL Profiler? That was actually a tool that was used to analyze your workloads. And that was really cool for analysis services. And they actually have this kind of subclasses which allow you to define what is happening here. And there is a new subclass that came up with this aggregations, which is called rewrite attempted. And this aggregation is actually doing what the name says. So I was querying the sum of the column passenger count in my trip table. And the engine is now looking, do I have a combination? Do I have an aggregation type over a column in a fact table with a combination of dimensions assigned to it that allow me to actually use the aggregation table to rewrite my query to use the aggregation table instead of using the detail table? And that is what happened. And the rewrite attempted found a match found. And it actually changed the query to use the, now I have to scroll down and hope that this works, to use the aggregation sum passenger count from the aggregation table. So that is actually a success. So that is why this query was so fast. And as I mentioned, we can do the same thing by this month name attribute. So the aggregation table is not related to the fact to the date table, but we have this group by month name. And this actually leads to exactly the same result. So the rewrite attempt matched and the data was taken from the trip aggregation table, so the aggregation table, and was actually executed on month level. If I would go down to day level, it wouldn't work any longer, but on month level, it actually works. So that was a quick demo of composite models and aggregations. The really, really cool thing about composite models is, just to mention this, up to December, it was not able, it was used to combine direct query and import model or other direct query models, but it didn't work on live connections. So it didn't work on multidimensional models. And the cool new feature from December or available since December is that you can now add a live connection to a composite model or create a composite model based on a live connection, because now Power BI Desktop is able to change a live connection to a full direct query. why do I say to a full direct query? A live connection so far was just a reference saying, connect to this data model and get everything from there. But the Power BI model itself didn't have a real definition of the data model. Live connection was like a kind of pointer, but no definition. Direct query still contained the meter information of the model, not the data, but the model information. And now you have the possibility to turn your live connection into a direct query mode. And with this, you now are able to also include multidimensional data sources into a composite model, which means if you, for example, have a sales model and an inventory model, you could actually combine those models to a general business model, for example, which would mean you don't have to rewrite everything. You don't have to upload the data twice, but you can run combined queries on both existing Power BI datasets. And as I already ran over time a few minutes, I will leave it with the demos at this point, and will shortly come back to the slides, because I just want to highlight on the features that are still missing to close the gap between Azure Analysis Services or Analysis Services standalone and Power BI. So what is in Analysis Services, what is not yet in Power BI? First of all, we have object level security, meaning at the moment, a user can get access to a Power BI dataset, and by this, the person gets access to all objects in that data source, in that data model. You don't have the opportunity to say you only get access to certain tables inside this model. This is something which is missing, and as you can see by the link, there is announcements on that on the roadmap. So wherever there is some information I could gather, I pointed to those. We have asynchronous refresh, which is also in work. We have log analytics integration, also in work. We have backup and restore. That is something which in Power BI is not possible out of the box. So you cannot back up the data set and republish it. You always would need to publish it from the PBIX file itself, completely anew, and run all the loads again. And we really desperately hope that this will come, because from an enterprise BI perspective, that is really interesting. And what is still missing is query scale out. So with Azure Analysis Services, you can just create read-only replicas of your server to help out in cases of high concurrencies, to actually perform a kind of load balancing on more servers. This was not possible so far in Power BI, but with Power BI Premium Generation 2, there is a first approach of this. So with this, you can, for a short time, create a second node, so a second capacity node, to actually fulfill exactly this requirement, which for sure will cost something, but which can dynamically be scaled up and scaled down again. So a first step into query scale out is also possible. So with this, I'm a few minutes over time, and I would like to stop here and at least have a few minutes left. I guess about 5 minutes left for questions. And yeah, sorry about overdoing it a bit, but there are so amazingly interesting topics in modeling in Power BI.
Luckily, we have a lot of questions. The first question is, you create the models in Power BI to help people doing correct reports. When considering advanced developers and citizen developers, can we somehow miss the target and do too simple models or too complex models? Or are all models equally easy to use?
The answer is definitely yes, you can do both too simple and too complex models. I fully agree. So a feature like perspectives that you had in Analysis Services standalone before, and I'm actually, to be honest, I'm not sure if that's already possible, but I think it isn't yet. Perspective was a way to create a complex model in the first place, and to hide parts of this model to make it easier for certain target groups. This would be very useful. At the moment, that's not possible. A way could be the new composite models by creating a complex model in the first place, and by creating a composite model and just using a subset of this, creating simpler models on top. But just to mention, this is not yet possible in the composite models on multidimensional models. At the moment, you cannot delete tables from the models you're connecting to. With the normal direct query source, you can actually decide table by table what you want to use. With the composite model on direct query, you can't at the moment. So bit awkward, maybe on a good way, but not there yet. Long answer for actually yes.
So next question, can our Power BI data models utilize complex data modeling concepts such as role-playing dimensions and conformed or shared dimensions?
No, definitely not. So role-playing dimension is a typical example. We are solving this by creating a table in Power Query for the dimension itself, referencing the table in the end. So you're doing the Power Query calculations only once, but talking about a date table, for example, and having a due date, an order date, and a ship date, for example, you would create either 3 different dimension tables for the date and combine each of those tables to one of the references in the fact table. That would be the easiest one to do all the calculations. The other opportunity is you can create 3 connections from the fact table to the same date dimension table, but only one of those connections would be active and could be used in the standard drill and slice scenario. But you can create DAX calculations on top of the other relationships because DAX allows you to activate relationships inside of calculations. So there are ways to circumvent this, but it's not really the same as role-playing, for example. And shared dimensions, not really. You're creating every data model on its own. You can use data flows to actually do the shaping in one way. Data flows would be ideal for this. So you can store the, let's say, the results of your M queries centrally and reuse those in different data models. But you still would need to do calculated columns you're doing in the data model, hierarchies, and so on in each and every data model again.
Perfect. I think I've just given you your next session, Gabi.
So a star schema is what I recognize from SSAS. Is the model in Power BI and the model from the cube interchangeable without any major redesign needed?
So let's call it like this. A model in a multidimensional SSAS solution, so in a cube and in tabular, don't behave in the same way. But setting up the, let's say, the same schema for fact and dimension tables makes absolute sense, yes. So if you want to recreate an existing multidimensional solution in a tabular mode solution, I would use the same schemas for the fact and dimension tables, apart from some details, like maybe partitioning is a special case, and we were talking role-playing dimensions yet. That would be treated differently in multidimensional, but generally the designs of the tables, I would say, is the same.
Okay, so next question. Are there any benefits to having a data model defined upfront first in Azure Synapse, aka SQL DW, as well as defining a data model within Power BI, assuming cost is not a consideration, or would that be overkill?
We are working with Synapse a lot in the moment, and so that is a question I really like. Generally, I would say yes, always. I'm missing the opportunity to actually create the Power BI model in Synapse yet. It doesn't make sense to me to be able to create a report in the Synapse Studio, but not the data model, but that might be just my opinion. But Synapse, in my opinion, is more like a data warehousing technique. So creating a star schema or a data model in Synapse would be like preparing the data model in the relational SQL Server, which I would have done in my on-premise world or my multidimensional world either way. So I still would always go with having a, let's say, relational data warehouse, matching my tabular mode or my analysis services data model is always a good thing. It makes understanding easier, it makes the way of the data easier, and Synapse is not only the data source to fill the Power BI model, but Synapse allows you to also offer the data model to other services and other solutions. And that is why I still think Power BI might be a mighty tool, and you might use other reporting tools to connect to the data models you create there. But still, it's a multidimensional model, and not all of the tools are working good with this. Synapse allows you to actually replace your current ODS, your current operational data store, which allowed you to have the same kind of data model in a relational way. So I still say, yes, it makes sense to have it in both worlds.
Cool.
Next question, do the cloud versus on-premises data source location have the same refresh rate limitations?
Yes. That's definitely the case. So for the on-premise, you for sure need a gateway, but this doesn't add to any kind of refresh limitation. So your refresh limitation in Power BI Pro is 8 times per day, which to my understanding is actually enforced. Your refresh limit in Power BI Premium is actually, honestly, none. You can refresh as often as you want to. The scheduler allows you not to do more than 48 refresh per day because the minutes allow only a selection of 0 and 30. But you can use tools like Power Automate or PowerShell or whatever to actually trigger refresh on the Power BI Premium dataset as often as you want to. Don't do it more often than it makes sense. So not every minute if the processing takes 5 minutes. This will just cause errors, but you can do it as often as you want. And that actually is not related to where the data source is located.
So next question, our understanding is that data flows save to data lake under the covers to persist the data flow data. Are there any performance or capacity limitations to just going with the default there, or should you use your own data lake storage?
To my knowledge, there are no performance implications in using the data lake under the cover, and I completely agree. Data flows are storing the results of the Power Query transformations in CSV files in the data lake. The big advantage of actually using your own data lake storage in this scenario is that you can expose the results of those data flows to other services as well. So you will not have them exclusively in Power BI. Although I have to add that I distinctly remember reading a blog post from a forum post from Imke Feldmann a few days ago saying that reading the results from Power BI data flows will be possible in Excel in the future in Power Query as well, which would be great. But at the moment, the results of the internal data flow, ADLS, is only accessible via Power BI, and using your own storage account actually allows you to expose this to other services. But it means you also have to pay for this storage account. No performance implication to my knowledge.
Cool.
From a scared developer, obviously, can we use Power BI without DAX?
No.
Good answer. Thanks.
So given that Azure Analysis Services only supports tabular models, should we now avoid using dimensional models for new development?
Yeah, so I would say from a lot of discussions we had even with the product group, at the moment I would actually be, well, I would actually make a guess and say multidimensional will never come to the cloud, apart from as infrastructure as a service. So if you're good with running a VM with analysis services multidimensional installed on that in your scenario, then you can stick to multidimensional. Creating new models in multidimensional, if you're heading for the cloud, is probably a bad choice.
Okay.
Another developer related, can you do modeling against a server or a database named something? and then change the connection to something else when you deploy the reports?
Yes, actually deployment pipelines offer you a solution for this already. That is the DevOps part I was mentioning. So this is the classical ALM strategy. So you have different environments, dev, test, and prod. And there, for example, you can assign data source settings. So when you're publishing from dev to test, you can say, instead of using the dev SQL Server, use the test SQL Server. So this is actually on automatics. On the other hand, if you're using PowerShell to actually publish content to workspaces in the service, you have a so-called rebind API. It's definitely available in PowerShell. I'm not 100% sure about the REST API, which allows you to connect your report to a different data set. So if you would, for example, have a dev data set and a prod data set, you could just change the connection inside the report, which does not answer the question completely. But that would be a case. Doing this during deployment should be possible as well. So if the deployment pipelines do it, I'm rather sure you can do it with one of the APIs as well. But I couldn't say out of the head with which commandlet.
Okay.
Deployment pipelines can do it, so I assume the API can as well. Rebinding a report to a different data set for sure definitely is possible.
So you talked earlier about the fact that Power Query is kind of making its appearance in other Azure services.
Yes.
One of which was that you hadn't mentioned was Azure Data Factory wrangling flows. I forget what the new name is for that. So is it possible, therefore, to implement complex automation outside of Power BI to build and update your Power BI data models? Or is that a silly scenario?
Oh, it's not a silly scenario at all. So I didn't look into the Azure Data Factory automation for quite a long time. I looked at wrangling data flows a few months ago and wasn't convinced.
Okay.
It definitely got way ahead since then. I think the new name is just Power Query Activity, but right. Not too sure. It's rather simple. It's actually available in this scenario also very, very recently. I would like to look into this, but actually the scenario of Power Query inclusion or implementation in Azure Data Factory is more the same scenario as you're having with Power BI data flows. So it's not really meant to update your data model. It's actually meant to replace the shaping of your data that you would do in the Power Query part of your Power BI preparation. So you still would need to create your data model on top of the results from the Azure Data Factory load in Power BI afterwards. So this wouldn't replace this part of the whole scenario. It's the shaping, the ETL part, but it's not the modeling part.
We've come to the last question here, and it says direct query used to impose certain restrictions in what we could or couldn't do, such as limited data source support or inability to query tabular models using MDX. Do any restrictions that we should be aware of apply today?
To my knowledge, all of those limitations are still there. I don't distinctly remember that any of those limitations have been removed. The only thing is this kind of allowing a direct query model on top of a multidimensional data source to include those multidimensional data sources into a composite model. That is new. But this still would mean that a multidimensional model would be queried using DAX instead of MDX. And as this is a very, very new preview feature, this doesn't support all of the multidimensional data sources. It's probably only Power BI datasets and Azure Analysis Services at the moment. So even that is not a solution for all of this at the moment, but it's meant to at least solve some of the issues. But still, with using direct query, you have the limitations you had before, like not all of the DAX statements are supported and other issues. So to my knowledge, those limitations are still existing.
Perfect, thanks.
My pleasure.
That would conclude our questions and the session here. Thanks for joining us, and a big thanks to Gabi for spending time with us.
As I mentioned, it was my pleasure. Dankeschön from Germany. Thanks for having me, and thanks for giving me a really good time. Thanks a lot.